Hello and welcome to this in-depth exploration of the fascinating and terrifying history of nuclear power and nuclear weapons. From the groundbreaking scientific discoveries that unlocked the power of the atom, to the devastating nuclear bombs dropped on Japan in World War II, to the tense nuclear arms race of the Cold War era, to the peaceful use of nuclear energy today, this is a story of immense scientific achievement intertwined with the potential for unimaginable destruction on a global scale. We'll dive into the pioneering work of the physicists who first split the atom, the top-secret Manhattan Project to develop the first nuclear weapons, the utter devastation wrought on Hiroshima and Nagasaki, and the ensuing nuclear arms race that brought the world to the brink of annihilation. We'll also explore the development of nuclear power, the major accidents like Chernobyl, and ongoing controversies over nuclear waste and proliferation. So let's begin our journey into this transformative and controversial technology that has shaped the modern world like few other scientific advancements. The discovery of nuclear fission, 1938. Our story traces its roots back to the late 19th century, when scientists like Henry Becquerel and Marie and Pierre Curie first discovered radioactivity, the spontaneous emission of energetic particles from unstable atoms. This kicked off decades of pioneering research into the mysteries of the atomic nucleus and the subatomic realm. It wasn't until 1938 that the breakthrough discovery of nuclear fission was made by Otto Hahn, Lise Meitner, Fritz Strassmann, and Otto Frisch in Berlin. They found that when shooting a stream of neutrons at the heavy element uranium, the uranium nuclei could actually split apart into lighter elements in a process releasing tremendous amounts of energy and more neutrons. This nuclear fission process, if sustained in an ongoing chain reaction, could potentially unleash astonishing quantities of energy, according to Einstein's famous equation E equals mc2. News of this revolutionary discovery spread rapidly through the scientific community, as physicists realized its potential applications, both for an unparalleled new energy source or for an incredibly destructive weapon unlike anything ever seen before. Scientists flee Nazi Germany. Among those who grasped the significance of nuclear fission were two German chemists and Nobel laureates, Fritz Strassmann and Otto Hahn. But as Jewish scientists living under the repressive Nazi regime, they faced increasing persecution and discrimination. In July 1938, they wrote a letter to physicist Lise Meitner, who had earlier fled to Sweden, describing their baffling results of uranium nuclei splitting apart. Meitner, along with her nephew Otto Frisch, correctly interpreted these findings as nuclear fission, providing the theoretical explanation for this phenomenon. With many other top nuclear scientists like Enrico Fermi and Leo Szilard also fleeing Europe, the scientific leadership in nuclear physics began to shift toward the United States and allied nations. This brain drain of Jewish scientists from Germany turned out to be a crucial factor, allowing the U.S. to develop nuclear weapons first during World War II. The Manhattan Project, 1942 to 1945. Alarmed by the possibility of Nazi Germany developing nuclear weapons, Albert Einstein himself wrote a letter to President Franklin D. Roosevelt in 1939 warning of this potential threat. This led to the launch of the top-secret Manhattan Project in 1942, under the leadership of the U.S. Army Corps of Engineers. The Manhattan Project was a remarkable collaborative effort involving the mass mobilization of economic and scientific resources on an unprecedented scale. At its peak, it employed over 130,000 people across dozens of sites at a cost of around $2 a billion, the equivalent of over $30 a billion today. The project's brain trust included many of the era's top physicists who had fled Europe, like J. Robert Oppenheimer, Enrico Fermi, Leo Szilard, Eugene Wigner, Edward Teller, and Richard Feynman. They gathered at the remote Los Alamos laboratory in the New Mexico desert to overcome the immense technical challenges of producing fissile materials and developing a working nuclear bomb design. After years of intensive research, experimentation, and problem-solving under immense wartime pressure, the Manhattan Project achieved its goal. On July 16, 1945, they successfully tested the first nuclear bomb called Trinity in the New Mexico desert, ushering in the atomic age with a blinding flash brighter than a dozen suns. Hiroshima and Nagasaki, 1945. Just a few weeks after the Trinity test, with World War II raging in the Pacific, the decision was made by the United States to use these powerful new weapons against Japan in an effort to finally force their surrender and bring an end to the bloody conflict. On August 6, 1945, the uranium bomb code name Little Boy was dropped by the Enola Gay bomber on the city of Hiroshima. The explosion had the force of around 15,000 tons of TNT, generating scorching heat up to 5,400 EG-F and intense radiation. It killed around 70,000 people instantly, with many more dying later from radiation sickness. 3 days later, on August 9, the plutonium bomb, Fat Man, was dropped on the city of Nagasaki, killing another 40,000 people. These remain the only two instances of nuclear weapons being used in warfare to date. The sheer scale of death and destruction caused by these bombings was like nothing the world had ever witnessed before. While the ethical implications of using such indiscriminate weapons of mass destruction on civilian populations remain hotly debated, the bombings did succeed in forcing Japan's surrender on August 15, 1945, bringing an end to World War II after years of devastating conflict. The nuclear arms race begins 1949 to 1991. In the aftermath of World War II, the United States held a temporary monopoly on nuclear weapons. But this would not last long. Driven by the intense ideological and geopolitical rivalry of the Cold War, the Soviet Union was feverishly working to develop its own nuclear capability. In 1949, the USSR successfully tested its first atomic bomb, launching a nuclear arms race between the two emerging superpowers that would last for over 4 decades. Both sides rapidly built up their nuclear stockpiles, developing increasingly powerful hydrogen bombs that were thousands of times more destructive than the weapons used on Japan. By the 1960s, the United States and Soviet Union had amassed enough nuclear firepower to essentially destroy human civilization, many times over in an all-out nuclear exchange. The doctrine of mutually assured destruction, aptly named MAD, acted as a deterrent, as neither side could launch a nuclear attack without guaranteeing their own annihilation in retaliation. But there were many close calls and tense standoffs that brought the world to the brink of nuclear war, like the Cuban Missile Crisis of 1962. For 13 harrowing days, the US and USSR came perilously close to firing nuclear missiles at each other after Soviet nuclear missiles were discovered in Cuba, just 90 miles off the Florida coast. Nuclear proliferation and near misses. As the decades wore on, more nations like the United Kingdom, France, and China successfully developed and tested their own nuclear weapons, joining the club of nuclear-armed states. Both the US and USSR also came disturbingly close to accidentally launching their nuclear missiles on several occasions due to technical glitches, misinterpreted radar data, or human error. One particularly harrowing incident occurred in 1983 when Soviet nuclear forces went on high alert after the military's warning systems showed that US missiles had been launched against them. It turned out to be a false alarm, but the future of human civilization may have hung in the balance of one Soviet officer's decision not to launch retaliatory missiles based on his gut instinct. The frightening prospect of nuclear terrorism by rogue groups or nations also became a major concern, especially after the 9/11 attacks. If extremist groups were to acquire even crude nuclear weapons or radioactive dirty bombs, the consequences could be catastrophic on a regional or global scale. Nuclear power and accidents. While the nuclear arms race dominated the headlines, the 1950s also saw the development of nuclear power plants for peaceful energy generation. The first commercial nuclear power plant opened in Shippingport, Pennsylvania in 1957, ushering in a new era of carbon-free energy production. Nuclear power plants work by using nuclear fission to generate intense heat, which produces steam to spin turbines and generate electricity. While nuclear power currently provides around 10% of the world's electricity, it has always been a controversial technology due to concerns over safety, radioactive waste storage, and potential links to nuclear weapons proliferation. The world witnessed the potential dangers of nuclear power with the 3 Mile Island accident in Pennsylvania in 1979, which came perilously close to a full meltdown of the reactor core. Then the much more severe disasters of Chernobyl in 1986 and Fukushima in 2011 highlighted the catastrophic risks of nuclear meltdowns, radioactive fallout, and environmental contamination. At Chernobyl, an explosion and fire at the nuclear plant in Soviet Ukraine released massive amounts of radioactive particles into the atmosphere, forcing the permanent evacuation of over 100,000 people and leaving entire towns as radioactive ghost cities. It is considered the worst nuclear accident in history. The end of the Cold War, 1991. After decades of escalating tensions between the US and Soviet Union, the Cold War finally came to an end in 1991 with the collapse of the Soviet regime and the dissolution of the USSR into independent republics like Russia, Ukraine, and others. With the existential threat of global nuclear war subsiding, both the US and Russia began drastically reducing their nuclear stockpiles through a series of arms reduction treaties like START and New START. By 2022, the number of nuclear weapons had been slashed by over 80% compared to the peak Cold War levels. However, the threat of nuclear weapons did not disappear entirely. Other nations like India, Pakistan, Israel, and North Korea have since joined the list of nuclear-armed states. And the risk of nuclear terrorism or regional nuclear conflict remains an ongoing concern in the 21st century. Modern nuclear issues in the future. Today, there are still around 13,000 nuclear weapons in the world, with the vast majority held by Russia and the United States. The Nuclear Non-Proliferation Treaty aims to prevent the spread of nuclear weapons to additional nations, but has had mixed success as some nations like Iran have allegedly pursued covert nuclear programs. There are also ongoing debates about the future of nuclear power as an energy source. While it provides carbon-free electricity with a relatively small environmental footprint compared to fossil fuels, the potential for serious accidents, difficulties with long-term radioactive waste storage, and potential links to weapons proliferation remain major concerns. New and potentially safer nuclear technologies like small modular reactors, molten salt reactors, and nuclear fusion are being explored. If the scientific challenges of fusion can be overcome, it could one day provide a virtually limitless source of clean energy by replicating the fusion processes of the Sun here on Earth. But the development of fusion power has proven to be a long and difficult road, with major scientific and engineering hurdles still to be cleared. The International ITER project in France, a collaboration of dozens of nations, is one of the most promising efforts to finally achieve sustainable fusion energy in the coming decades. Closing thoughts. Overall, the history of nuclear technology is one of incredible scientific progress intertwined with both immense destructive potential and promising peaceful applications. The harnessing of the fundamental forces within the atomic nucleus has given humanity access to an extraordinary new source of energy. But it has also produced weapons of mass destruction that could potentially end human civilization as we know it if used in an all-out nuclear conflict. As we look to the future, the challenge will be continuing to develop and benefit from nuclear technology for power generation, scientific research, and other peaceful purposes, while avoiding the catastrophic risks of nuclear war and proliferation. It is a delicate balance that will require international cooperation, responsible stewardship, and a commitment to prioritizing human security over national rivalries or ideological conflicts. The nuclear age has been one of both great achievement and great peril for our species. How we navigate this dual legacy moving forward will be crucial for the fate of our planet and the future of humanity. Thanks for watching and please like and subscribe.